Now let's look at task C. Task C is about mapped programming. So you can read this part about data. Suppose that there's a big file. So some students ask me whether they need a real big data file for this task. The answer is no. No, you don't have to. Just imagine that there exists one big file, including student records, and the file might include billions of lines, and each line includes some information like student ID, gender, course ID, course grade, school year. So there's some examples here. Okay. So your task is to produce some pseudocodes to deal with the task assigned to you. Okay. So you don't have to do all of them. You just pick one based on the last digit of your student ID. So you can see that this example. So you have to select the right correct task assigned to you. For example, if this is your ID, the last digit is 0. So according to this function, if your last digit of your student ID is 0, 1, you have to select task 1. Okay. So based on that, you will select the task assigned to you. Okay. This special case, if you see that in your student ID, actually 4 is the last digit of your ID. Okay. So because in the system, I can't see this part. I can't see this part. So that's why 4 is your last digit. So based on this function, the last digit is 4, so you have to select task 3. Okay, so that's something I need to highlight. If you select wrong task, you might get 0 for this task. So if you are not confident about selection of your task, you can contact your tutor or drop email to me. Okay. Okay, let's go back to the task. You just need to select one of the tasks. So you can see that task 1 outputs average grade for each course for the year 2021. At second task outputs a minimum grade for each course for the year 2022. And the third one outputs the schools and their student count for the year 2023. Task 4 outputs the number of female students for the year 2024, and task 5 outputs the number of courses for each year. So you just pick one, the task assigned to you. I think it's easy to understand, right? The meaning of data and the meaning of your task. But if you are not confident, you can ask your tutor or drop email. Just one thing I need to mention. I think there's some tips for you. That is, if one student actually can appear in the multiple records because if student select modules, right? So I think, for example, this one as student SC00112338. This is student ID, right? It's a unique ID for each student. So this student might select module, big data, right? 702, this big data module, right? And got, more 685, right? But normally, the student might must select other modules, right? Like 1800 information visualization, right? Of CM school, right? Or 1835 advanced database, right? So you can tell actually the student ID, that student actually could appear in multiple records or multiple lines in this big file. So when you do this task, when you design your codes, you have to keep this in your mind. Okay. So I think that's quite important, right? So you need to keep this in mind. One student might appear in multiple records, multiple lines in this big file. Okay. So keep this in your mind. Okay, that's some tip I could give you. Then I just want to highlight some requirements. for your task. Okay. So actually, the MapReduce programming this task is highly relevant to lecture in week 4. Lecture in week 4. Okay. So you can tell yeah. So yeah, week 4 advanced map programming. So you can review the lecture slides if you forgot something, or you can review the lecture video. Okay, you want know details about designing map function, reduce function, how to write pseudocodes. Okay, so you can have a review the lecture slides, or if you want, you can also watch lecture video. Okay, recorded lecture video. Okay, and yeah, so only this requirement I want to highlight. Only pseudocodes are accepted. Accepted. Okay, so you can't provide me the Python code, Java code, any real codes are not accepted. You had to write pseudocodes. We taught the way we taught in advanced MapReduce programming in the lecture. Okay, following the framework I have taught you in the lecture. So that's why if you're not confident about how to write pseudocodes following the framework of MapReduce, you can double check, the lecture slides, and watch, the lecture video. Okay, lecture video. Okay. Okay. So pseudocodes you must have for this task, and the code should be written in your report. The codes must be written in plain text. Okay, plain text. You can't, provide me a screenshot of your codes. It's not acceptable at all. You might get 0 for this part. Okay, so no screenshot for the codes. The code should be written in plain text. Okay. Okay, so now I just gave some information for writing pseudocode. So I think during the lecture I mentioned that if you design your pseudocode, you have to include at least two classes, right? Mapper and reducer, right? And design map function or map method for mapper, and reduce function or reduce method for class reducer. Okay, so that they are necessary. You must include them. This is a framework you have to follow to design your pseudocodes. And some parts should be quite clear, including the key value pairs for input, output of map function or reduce function. Okay, because you know that designing pseudocodes or designing map reduce program, the input out key value pair should be one of the cores of designing MapReduce, algorithms or codes. So should be clear. The key value pairs for input and output of the map function, reduce function, quite clear. Okay. Okay, so you can. I hope you could have read about our lecture slides or in week 4. So I gave just one mention that. Yeah, no, this one. This is a very basic one. The basic one. So you can tell we have two styles. I think during the lecture I mentioned that we have two pseudocode styles. You can select one. This pseudocode 1, this pseudocode 2. So it's up to you. Up to you. But you should include class mapper. This is a pseudocode for word count example, contains the number of occurrences of each word in in one document or multiple documents, whatever. So you can tell this for word count example, you include pseudocodes, include two classes, mapper and reduce, right? And for mapper, it includes one method, map. Document ID, document content, they are actually the input key value pair, right? With map method or map function, whatever. And this is behavior, right? Behavior of map function. And emit, that means sending out some key value pair, right? Key value pair. This term key count 1 is value, right, for each key value pair, right? So this is map function or map map cluster and map function or map method, whatever. So you can tell the input key value pairs, the output key value pair are both clear, right? And for reducer, you had to do the same thing. Design a reducer class, design a method reduce method, with key value pair at input. Okay, so for this example, what kind of example? Term T is key, right? Term T, and value is a set of some elements. In this example, a set of counts, right? Counts. C1 actually one, a lot of ones, right? And this is behavior, right? Including this method. And output, the emit, that means output, sending out key value pairs, and term T and S is a count, sum up all counts included in this, in this set, right? Okay, so this is pseudocode 1. So you can also consider use pseudocode 2, the style, okay? It's up to you, but you can tell actually they are very, very similar, right? Okay. So I would highlight again, mapper, reducer, two classes should be included, and two function or method map and reduce, and the key value pair for map function, output key value pair for map function, input key value pair for reduce function, output key value pair for reduce function. This should be clear, okay? Should be clear. Okay. So you can follow the styles to design your own pseudocodes for your task. Okay, so one more thing I need to mention is combiner, because I think the requirement for this task, your algorithm should be efficient, should be optimized, well optimized. So that means you have to consider the problem of efficiency, right? Your algorithm should be efficient. So how to make your algorithm efficient? I think during the lecture we introduced some the concept of local aggregation, right? I hope you could if you remember local aggregation, right? So that require you to design something to keep, to do some local aggregation, right? So you can consider design combiner or in-map combiner. If you want design, combiner, you could consider use this style. Okay, I think I have introduced during the lecture. So if you're not confident, you forgot something, you can double check the lecture, recorded lecture video, record the lecture video here. Okay, you can have watch. Okay, so you can see that. Or if you know the drawback of this combiner, so you have no control on how many times your combiner to be executed. You have no control on that, and sometimes it's also very slow. So we discuss the second way to improve performance, that is the in-map combiner approach. Okay, you can have a check. And if you want to design in-map combiner, so you need to follow that style, right? So you can see that we have more methods. The first one, initialize method. Second one, map method. The third one, the close method, is responsible for sending out, emitting or sending out, key value pairs in at last. Okay. The reducer is as before. Okay. Or second style, pseudo style, you can see about same. There's some a little bit difference, but you can tell they do similar thing stuff. So if you want to design a map combiner, you can follow that way. Okay, mapper, you can combine your in map combiner inside the mapper, right? Inside the mapper, so I can tell. Okay, you try to use in-map combiner to improve performance. Okay. So if you want to make your algorithm more efficient, you could consider to design combiner or in-map combiner and design your pseudocodes based on the framework we have discussed in the lecture. Okay, so you can if you want design in-map combiner, you can consider design pseudocode like this way. Or if you want design component, you can consider to use the code like this, pseudocode like this. Okay, follow that way. Okay. Okay, so that's the requirement for discussing the efficiency of the algorithm. But you have to design, explain your codes, explain your design. So something I have highlighted here, like you can read the requirement here, but I need to highlight something. First one, of course, you have to describe the input/output key value pairs for map function, and of course, input and output key value pair for reduce function. Okay, that's quite important to explain, input, output, right? And describe, the how, the output key value pair generated by map and reduce functions, right? You just describe the behaviors of your map function and reduce function, right? And how the data transfer from mapper to reducers during the shuffling stage. So you need to explain the shuffling stage for your design, not for general purpose, just for your design, how your key value pair is generated by your map function, transfer to corresponding reduce function. You have to explain the shuffling stage for your specific design or specific your algorithm. Okay, and you also need to describe, discuss the efficiency of your algorithm. Efficiency, I have mentioned that. You have discussed something about combiner, in-map combiner, whether you have designed combiner or in-map combiner, right? And how they work, right? How you just pick one, if combiner or in-map combiner, and how it works, and why it could is able to optimize your algorithm, with respect to time efficiency, right? And not this. I won't want to read something about time complexity analysis. That time complexity analysis normally for sequential algorithm, sequential design, not for distributed design. So if you want to discuss the efficiency of your algorithm, please focus on this part. Whether you have design combiner or in-map combiner, and how it works, why it works, why it's helpful for optimizing your algorithm. So that's something I want to read from your report. Okay. And again, I just want to highlight again, your discussion, your description should be clear and very specific to your task. I don't want to read something too general. What the map function for, what the reduce function for general purpose. I don't want to read that. Sharpening state. I want to read something about your own description to your own design. Okay, your design. Okay, so please avoid some general discussion to map, reduce, to the efficiency, to even to combiner or to in-map combiner. I want to see how they work in your case, in your design. Okay. And last one, no one limit for task state. Okay. So you can write down, in that words, if you need. Okay. Yeah. So that's my, information for task. One more thing I need to mention. I forgot to mention. Actually, we have another more complicated example for map-related programming, because the lecture slide includes some simple examples for what count that example, right? So if you want to see a more complicated example for map-reduced programming, you can go to model page. And in week 4, we have lab 1 task. Okay, that includes a complicated example. I think it's similar to your coursework task, right? So you can have read. This is the task, right? So and this is pseudocode. I think this is pseudocode optimized with one in-map combiner. Okay, so if you want to design your code for your task, you can read this example and try to understand the pseudocodes. and design something, you can borrow some ideas from this example.